Hello, this is a real brief video about how to calculate the pH of a solution. As a quick reminder, a pH scale is a measure of how much acid is in solution. 7 means that it's a neutral solution. A pH below 7, a value below 7 means that the solution is acidic. A pH above 7 means that the solution is basic. So our pH is a measure of the acidity of a solution. Okay? Just really brief, the most basic definition of an acid is something that produces H plus in solution. That's the Arrhenius definition. The Bronsted-Lowry definition focuses on transfer of protons, but either way, an acid will produce H plus in solution. Now, another thing that can be confusing about acids is that in solution, H plus is actually present in the form of H3O plus. So we use these two terms interchangeably. H plus means the same thing as H3O plus. H3O plus means the same thing as H plus. But what is different is the words. H plus is called a proton. H3O plus is called hydronium. But either way, they're the same thing when it comes to calculating pH. So we can calculate the pH if we know either the proton concentration or the hydronium ion concentration. To calculate the pH of a solution, we have to know what the molarity of the acid concentration is. So the molarity of the protons or the hydroniums, and as a reminder, molarity is calculated as the moles of the solute divided by the liters of solution. So the moles of protons or hydroniums divided by the liters of solution. All right, finally, another thing on the notation, we have brackets surrounding either the hydronium or the brackets surrounding the protons. Again, these are considered the same thing when it comes to calculating pH. The brackets mean molarity. So if you see brackets around something equals a number, that means that equals the molarity of that thing. So this means molarity of hydronium. This means molarity of protons. Now that we've got our terminology down, we can take a look at how we actually calculate the pH. The pH is equal to the negative log of the concentration of protons, or the pH is equal to the negative log of hydronium. So again, we use those two things interchangeably. It can be either one, but we take the negative log of that concentration, and that will give us the value of the pH. Now that we have the formulas and the terminology down, let's work a sample problem here. Calculate the pH of a solution that is 0.025 molar concentration in protons. So what we're going to do is we're going to use this equation, pH equals the negative log of the acid concentration. We just simply take this concentration and plug it in, pH equals negative log of 0.025. I'm going to show you on your calculators two ways to do this, or two different calculators. So the simplest calculator looks something like this, and we've got our log button there. In calculators where you just have a single line and you can enter numbers only, you have to put in the number first. So I'll say 0.025, and then I will push the log button, LOG button, and that gives me the value. So we've got, from this calculator, the pH equals negative, and the answer is negative 1.60 if we round it to that decimal place. Now these two negatives cancel out, so the pH equals 1.60, clearly in the acidic range. Just to show you on a calculator that has a two-line calculator, it's a little bit more advanced calculator. Our log button is right there, there's LOG. But in this case, with these calculators that are more advanced, you want to put in the full equation like it is. We want the negative, sorry, look at this up here. So click it off. And use this negative button here. I want to do the negative log of 0.025. And then you can just hit enter, and you can see that gives me the same value, pH 1.60. As a final exercise, I want to show how we can go from pH back to concentration. So if our equation for pH is that it's the negative log of the hydronium ion concentration, then through our rules of algebra, the concentration of the protons will be equal to 10 raised to the negative pH. So if we have a question that is listed like this, calculate the concentration of hydronium ions of a solution with a pH of 11.5. Well, so now we want to know what concentration is, and we're given the pH. So we're going to use this equation to calculate the concentration by plugging in the pH value up there. So this will look like the pH, the concentration of the hydronium ions equals 10 raised to the minus pH, or the hydronium ion concentration equals 10 raised to the minus 11.5. So let's do this on our calculators again. On a more simple calculator, we can use the button above the log, the shift log button, because that's already got the 10 in there. In these calculators, you put the number in first, 11.5, and make it negative. And then I'm going to say second, and I'm going to push the log button, so I get 10 raised to that value. So we get an answer of the concentration of hydronium ions equals 3.16, and don't forget our power up here, times 10 to the minus 12. If you have a slightly more advanced calculator, let's clear this out. You go right to the button above the log. There's the 10 to the x, so I'm going to push second, push this button first. Let's clear that. Second, push that button first. So see, it gives me 10 raised to a power, and now I'll put in negative 11.5. And hit enter. 3.16 times 10 to the minus 12. We get the same answer. So that's a quick summary of very basic pH calculations.